переходим к следующему докладчику.
Рамис, секундочку, небольшое
Спасибо.
объявление. Сейчас следующий доклад будет на английском языке. Русскоязычные коллеги, для того, чтобы слушать перевод, воспользуйтесь функцией синхронный перевод. Он в Zoom внизу на панели, вы можете его увидеть. Выбирайте там русский и слушайте перевод. Рамис, пожалуйста.
Yeah, for our international participants, I speak English now. Please notice that the next coming presentation will be translated in form of video, but also will be translated into Russian. That's the reason of that, because our participants face problems with the connection, with quality of connection via Zoom. So please, I welcome Li Mingyang and first of all Han Bing, who would like to make some introductory words about his speech. Please start.
Рами, скажешь по звуку?
Здравствуйте, дорогие друзья! Я Хан Бин из Китая. Очень приятно снова встретиться с вами на ТРИС саммите. Простите меня за то, в связи с тем, что интернет не работает, мы будем использовать видеоформат для нашей презентации и постараемся по возможности общаться с вами в ревью. Сейчас мы хотели бы пригласить члена нашей команды, госпожу Ли Минgyang, начать нашу презентацию. Наши слайды на русском и английском языках. Мы не очень хорошо говорим по-русски, поэтому наша речь будет на английском языке. Спасибо. Hello, everyone. I'm Han Bing from China. Nice to meet you again at TRIS Summit. First of all, I want to apologize to all of you. Due to the internet regulation, we will take a video format for our presentation and try to have live interaction with you as much as possible. Now, we would like to invite our team member, Ms. Li Mingyang, to start our presentation. And our slides are in Russian and English. Please forgive us for our poor Russian. Our presentation and communication will be in English. Thank you.
Hello, everyone. I am Li Mingyang from China. It is a great honor for me to introduce our presentation. And the other members are Dong Yuehu, Han Bing, and Shi Xiaohua. They are all from China. Then, let me to introduce our subject to you. The topic is solving the problem of incomplete cleaning in the subframe manufacturing industry with trees. And it is a real case from the automobile manufacturing industry. Then, I will introduce the following aspects. Firstly, I will introduce the problem situation. Secondly, I will use function analysis to analyze the problem. Then, I will use some methods to solve the problem, such as trimming, effects database, technical contradiction, physical contradiction, and the field model. Then, after all of this, we will get solutions. Nowadays, aluminum alloy subframe is widely used in practice because it has lightweight and its strength can meet the requirements of use in practice. However, after machining, there will be impurities, such as aluminum chips, inside and outside the subframe. In order to remove these impurities, the subframe should to be cleaned. In the figure, we can see this is the cleaning part, and the manipulator drives the subframe into the cleaning fluid. Through the action of rotation, the subframe is cleaned in the cleaning liquid. But due to the complex structure of the subframe, it is difficult to completely remove the impurities, such as aluminum chips, in the cleaning process. And this is the drying part. It is used to dry the cleaning liquid on the surface and the inside of the subframe. But due to the use of the liquid cleaning solution, a derived problem is produced. It is that the subframe can't be completely dried after cleaning. And why is incomplete drying a problem? Or in other words, what harm will incomplete drying cause? Let we think about it together. Because if aluminum alloy subframe attached to the cleaning fluid, the subframe will be prone to rust and will corrode. And if the situation is more serious, the strength of the subframe will be damaged. So, the drying process is extremely important. And if we don't want to cause the derived problem of incomplete drying, we can consider changing the cleaning method. The existing available cleaning methods include advocation, gel, ultrasound, and electric field. For example, for the method gel, we can use relatively viscous fluid to move impurities. But a part of fluid will residue in the subframe, and it is difficult to clear in practice. And for the method ultrasound, its noise is very large. So, these methods are difficult to achieve in the actual cleaning of the subframe. Next, we will analyze and solve the problem around the use of liquid cleaning. So, based on these problems, the function analysis method is adopted to analyze the main problem that aluminum chips can't be completely removed. And what is the key issue in the function model? It's the effect of cleaning solution on removing aluminum chips is insufficient, as the figure shows. However, what is the fundamental reason of this key problem? The mixing wheel can't provide sufficient power for the cleaning liquid to achieve the cleaning function. So, the function of the mixing wheel is insufficient. And this is the fundamental problem we need to solve. By using the trimming tool, according to the rule 3, function carrier can be trimmed if another component performs its useful function. Then we cut the mixing wheel. Then the corresponding cleaning function will be replaced by the high-pressure nozzle, and the high-pressure nozzle is installed on the feeding manipulator. In this way, the cleaning liquid can be removed to everywhere of the subframe directionally. Thus, the cleaning process is more efficient. And at the same time, a support device is added to realize the transfer and support of the subframe from the cleaning zone to the drying zone. The above cleaning process can remove as much aluminum chips as possible. However, the cleaning liquid in the cleansing pond is mixed with aluminum scraps. It will cause the aluminum scraps to reattach to the subframe. So, we use the effects database to solve this problem. And two effects of centrifugal force and filter were found. In practice, we found that the second scheme is simpler than the first scheme, and it is effective. Then, a filter screen can be added at the outlet of the pipe to separate the aluminum scraps in the cleaning liquid. Now, we solve the derivate problem in the drying part. Then, we will solve the derivate problem, which is incomplete drying of liquid cleaning solution. By analyzing the functional model diagram, we found that the main problem in the model is that the heating function of the heat source and the heat dissipation device is insufficient in heating the subframe and heating the high-pressure air. And there is a technical contradiction. It is described as if a larger power heater is used, then productivity will be improved, but power will be deteriorated. About the contradiction matrix, we found two inversion principles. There are pre-action and escaping. According to the actual effect, we choose the first principle to solve the problem. The solution is to shake the frame before heating and drying to shake off some liquid. There is also a physical contradiction in this part. The heating time needs to be long because the subframe needs to be completely dry. However, the heating time needs to be short in the meantime because the process time needs to be as short as possible to reduce process time and save costs. Then, we use the separation in space of 4 separation principles to solve the problem. In space, 2 drying zones are set in the upper and lower positions, and then A cleaned subframe can enter the upper drying zone 1, and another subframe can enter the lower drying zone 2. Compared with the existing single pipeline equipment, the general drying time is greatly shortened, and in this way, each subframe can stay twice the required time in the drying area. That is, there is sufficient time to heat and meet the precise time requirement. Then we use the field model to solve the problem. And there are cleaning liquid, compressed air, and heat field. In the action of heat field, the effect of compressed air on cleaning liquid is insufficient. So we use the relative standard solution and induct vacuum field. Thus, by adding the vacuum field, the functional model becomes complete. Then, combined with the analyze just now, by using the trimming tool, according to the rule 3, we cut the heat source and the heat dissipation device, which is insufficient in the figure. And we make the related functions to be replaced by the removable compressed air heater, and it is installed on the unloading manipulator. Thus, high-temperature compressed air can be accurately blown to the subframe, and in this way, all parts inside and outside the subframe can be blown to by hot, high-pressure air, and it can ensure that the residual cleaning fluid is dried and distributed. Then we can get the final function model, and there is no problem with the function model after cutting. The functions are all sufficient. The mechanical arm carrying the compressed air heater can make the heating effect completely sufficient, and the high-temperature compressed air is provided with sufficient power and can heat inside and outside the subframe sufficiently. In the general, for the prime problem of incomplete cleaning, available solutions include: first, multi-degree of freedom feeding, spray integrated manipulator. Second, separation of aluminum scraps from cleaning solution by filter. And for the derived problem of incomplete drying, the available solutions include: first, shaking subframe before drying. Second, double drying areas. Third, multi-degree of freedom cutting manipulator with compressed air heater can be used. And according to the solutions above, the improved subframe cleaning device is shown as the figure. And this is the fading spray manipulator. It can realize the functions of fading grasping and directional cleaning. And this is the cross-layer transport device. It can make the two subframes interlaced for cleaning and drying process, reducing the total time of the process. And this is the multi-degree of freedom manipulator with compressed air heater, and it can realize the drying of the subframe and the function of cutting and grasping. Alright, that is our presentation. Thank you for your attention. Спасибо. And do you have any questions? You can write the question in the chat area. Thank you for your attention.
Well, thank you. Our speakers are here actually connected, and they are with us online, but they tried and they spent the efforts to prepare this recording in case they face the problem with quality of connection. So hopefully everyone could reach the content and find the material as well. Please, if you have questions, our speakers Han Ping and Li Minjiang are available to answer.
Yes, can you hear me?
Yeah, we hear you very well, Li Minjiang.
Yes. Due to the network here is not stable, so you can write your questions on the chat room.
Mikhail Rubin thanks you for the excellent example of analyzing a technical problem in an enterprise. We are particularly interested in the example of aluminum products. So it's very interesting, yeah, for us for our profile. Also from my side, I thank you. It's very nice to see technical analysis, especially for the function analysis. And my question here, while we are waiting other participants to ask if they want, did you feel any difficulties in the early stage for getting skills in this in practicing this instrument? And maybe you can tell us about specifics for the mentality for people in China in understanding such methods, or maybe they have their own approaches in this side, please.
In the process, the problem I meet is according please wait for a minute. The problem analysis is difficult for me because the device in the nowadays is have some questions, and how can we to use the how can we use to analysis the problem is a important way for me. And in this process, I use some methods to solve the problem, such as trimming effects database,
and all of this is from our teacher and from the network. So in this way is a little important, a little difficult for me from the from.
Why I'm asking that, because even here in Russia we face some problems with the new audience. I mean, with new solvers, problem solvers, in practicing such instrument. It's very sophisticated instrument and needs some skills in formulating functions in typical way, which we have in the method description, like generalizing the function naming, right? It's not the specific way where engineers use such description, but it needs some skills. I see. So you face a similar problem as in our audience.
Okay. Ramis, can you hear me?
Yeah, please.
Okay. Okay. Hello, everyone. Здравствуйте. I'm Hanbing from China, and firstly, I will say sorry to all of you due to the internet. And I will have a compliment for this thing. In fact, when we met a new problem, we will have more effect on the analysis of the problem. For example, function analysis. We should choose the right the object about this problem and make the function model for it. And it is if the function model is established, maybe it is more simple to solve the problem. In fact, we don't care which instrument or tools to solve it. We just care which tools can be solve the problem more effectively. Okay.
I see. Thank you. One more question from Mikhail Rubin. Is the project the result of the university's interaction with an industrial enterprise, and how does this interaction happen?
Okay. Yeah. Thank you, Rubin. I will answer your question. In fact, we just try to solve the individual and the typical problem, and maybe later we will try to enlarge or modify the samples and have the university's interaction, maybe. That is a typical problem. Just for the just for this just for this problem only, just for this project only.
Yeah, so this project comes from the enterprise to academic sphere, or how did you start such, or how did you initiate such project?
What can you speak more, please? Maybe the internet is not work for.
Once again, this project was initiated by enterprise or from academic sphere. From which point firstly begun? Do you hear me, Stefan? Well, anyway, I think we got the basic answer on this question, but also again, Mr. Han can answer by written form. And now we are preparing to switch. Thank you again for our participants from China, and we are now switching to the next